Hello everyone, welcome back for the last installment of the Chapter 10 homework solutions, where we hopefully, for you guys watching these videos, we're not just showing the solutions for the homework, of course, we're basically talking about the material for the chapter, and I hope that this will supplement anything that goes on for you guys as far as referring to the book or looking at any of the PowerPoints or anything like that. I know that there are some resources available on WebAssign as well. But before or without any further ado, I want to check out number 10. It says we're going to use the ordinary interest method. So of course that is going to be an important detail to notice. We want to compute the time for the loan. So we've seen interest, we've found rates before, we've found what else can there possibly be? There's principal. In this case, we're looking for the time in days, so we'll have to try to figure out how to do that one. Round your answer up to the next highest day when necessary, so we will pay attention to that little detail as well. We have, of course, three of the things that go into the formula, and the formula, if we think back to the triangle that we're looking for the time. And so whatever we're trying to find, if it's not interest, then the formula will go interest divided by the other stuff. So the other stuff besides time is principal and rate, and we want to multiply those in the denominator there. So if we plug in what we have the interest goes 224. We have also the principal, which is 7,400. And then we want to go times the rate, which is 10.4%. So we should put it as a decimal, of course, 0.104. And this time that we find, we will have to treat it a certain way because we're going to get a decimal, of course, as an answer. The decimal, though, that we get, because this time is always in years, that is an important detail to notice. The time here that we get is going to be in years. And then we will have to try to figure out how many days it is. But why don't we just do the calculation first? 224 divided by 7,400 and then times the rate, which goes 0.104. We get 0.291. Probably it will be safe to round it there, 0.291. And this is years. So what we're going to do is we can set up a proportion where we can say this many years, 0.291, is how many days, which I would just put X, some number of days out of, and it's ordinary interest method, out of 360. So if we put that many days out of 360, it should give us this decimal 291. And we can, of course, come here and multiply both sides times 360 times 360. It will cancel on this side. And then we will have this, and I will actually not have to round at all. I would just keep that answer and go times 360. So it's 104.7. It says to round up to the next highest day if it's necessary, so we will go with 105 days. Very good. And we have, in this case, another chance to calculate the number of days for this loan. It's going to be probably very similar to the problem that we just did. We have percents, which is not going to be applicable for us. Days should be to the next highest day. So let's just get going with it. We have the time is going to be the principal. In the denominator, we have interest on top. Principal in the denominator times rate. So that's going to be 730 divided by, what do we have? We have 17,000. It's going to take up too much room. I'm going to put 17K. And then times the rate, which is 13%, so that's going to go 0.13. And what will we get? We have 730 divided by 17,000 times the rate 0.13. That will go 0.3303. We just saw, though, since we're using, again, the ordinary interest method, basically we will take this many years, which is 0.33, and go times 360 days per year because it's ordinary method. And we will get a number of days, which if we round this one up, it's going to go 119 because it goes 0.9. So 119 days. Oops. And then, of course, the maturity value. Here we have the familiar one that goes the maturity value is the principal plus the interest. And so we're already given both of those values. If we add them, principal plus interest, it's going to go $17,730. Now, moving on to number 12, says that Michelle Payne deposited a certain amount, $16,000, into a savings account paying 6.25% simple interest. Wants to know how many years will it take for her investment to amount to $24,000. And since this is the whole investment, it includes her principal. You know, it's going to keep getting interest more. As soon as it gets up to $24,000, or in other words, once it has gained $8,000 in interest, it will be worth $24,000. So this is actually the value of the maturity value, the $24,000, because it's the principal and then also the interest together will make that up. Now, what can we do for the maturity value? Surely we can just keep in mind the formula for this one, which goes principal plus interest. And since I have it written above, this real estate is very valuable, so I'm not going to write it again. We're using this formula. And so if we plug the stuff in, and for interest, it perhaps would be I was thinking that it would be a good idea to put interest as principal times rate times times, which is a formula for interest, but why don't we deal with that later? We can have the maturity value, which is 24,000, equals 16,000, which is the principal, plus the interest. So we'll find out that the interest is, if we just subtract 16,000, it would cancel on this side, minus 16,000. This is the 8,000 that we were talking about before. The interest is 8,000. And of course, interest is principal times rate times time. We are already given the principal, which is 16,000. So we could actually plug in the principal and the rate into this one. So we can go 8,000 equals 16,000, which is the principal, times the rate, which is 6.25%. So we can go 0.0625 and then times the time. And I'm sorry it's getting a little bit scrunched up here, but we would like to divide both sides by this value, the 16,000 times 0.0625. We would like to divide by that on both sides. 16,000, I'll put 16K again just to save a little bit of room, 0.0625. These numbers are too long. I'm sorry that it looks a little bit jumbled, but we're going, of course, divided by 16,000 and also divided by 0.0625 and finding out that the time, because it cancels everything on this side, the time, which is all that's left on the right side, equals 8. And that's what we will get by dividing by that stuff. Very good. I'm glad that it came out as a whole number, 8 years. Now what about this one? This problem is actually going to be the most involved problem. And this is really quite, I would like to say, a tricky one, but it's not particularly tricky. You know, it just takes a few steps. But why don't we just get through here, because what we're going to talk about in this case is this idea of partial payments, where during the year, as it may be, of course, in this case it says 160 days loan. So during the middle of the loan period sometime, you're going to make a partial payment. Well, what's going to happen is that the interest is going to be calculated up to that point. When you make the payment, you will have to pay off the interest that you got that has accrued up until then. And then you're basically starting over with a new principal at that point, and then that's going to carry on until the next time you make a partial payment. And then we will just repeat the same process again. So it will be more clear once we get a little picture here. I always like to draw a picture about it, where basically this loan is a 160-day loan. So we will start on day 0, and then we will carry on until day 160, which is the end. And what happens is that the principal on day 0 is going to be $12,000. It's 7% ordinary interest all the time. The interest during the whole thing is 7%. But this says that after 40 days, so on day 40, you make a partial payment of $1,500. So what I want to do is calculate what is the new principal right now. But in order to do that, we need to find out what is the amount of interest. And actually, I'm going to come to a whole new page just to have a little bit more room for these calculations, because the last thing I want is for it to look too messy and be too difficult to follow. So on day 40, which of course the principal to begin with here is $12,000, we're going to make a payment of, right, this value $1,500. And so what's going to happen is that the payment that we make here of $1,500, it's going to be subtracted after what we're going to find is basically a mini little maturity value for day 40. So this is going to be the principal plus the interest up until now, which is going to be the $12,000 plus how much interest we gained with a 7% interest rate, 7% ordinary interest. Ordinary, of course, is going to be important for us because we're dealing with a number of days. So if we go plus the amount of interest, the interest goes, I'm going to just calculate it here. It's principal times rate times time. The principal is $12,000. The rate is 7%, goes 0.07. And I'll just write it so I don't forget again. 7% is the rate, and the amount of time is 40 days. We're using also ordinary interest method. I will write ordinary method just so that we can keep this one in mind. So the amount of interest is going to be after 40 days out of 360 days. And we can find this amount of interest. We can go ahead and calculate it. It's going to go 12,000 times 0.07 and then also times 40 out of 360. What's going to happen? The interest is $93. Oh, sorry about that one. $93.33. We will have to round it. So if we add the $93.33 to the principal, we will get the little maturity value for day 40, which this addition is actually easy enough to do. It's just going to be $12,093.33. And now we're ready at this point from this value, the 12,000, to make our little partial payment. And this was kind of an aside that went into this step. Now we're going to take our 12,093.33 and subtract our partial payment, which was $1,500, wasn't it? We make a payment of $1,500, so we would like to subtract that payment, $1,500. And now what's going to happen? I know that if you are very savvy, you will do the subtraction in your head, but for me, it was a little bit too difficult. It becomes $10,593.33. That's how much you're starting over with as basically a new principal at this point. You don't have to deal with any type of interest or anything again that happened during this period from day 0 to day 40 when you made this payment. Now we're calculating the interest carrying on from this amount, from the $10,593. So we make, after 60 days, another partial payment of $4,000. So after 60 days, we're going to be on day 100 But what is important for us is the amount of time that has gone by here, which is 60 days. That's the amount of time that we are getting more interest. We don't want to say the amount of interest for 100 days because this first 40, we already calculated interest for that. That's in the past. It's done with. We don't care about it. We're calculating interest for these 60 days. So the amount of interest here, this maturity value is going to be the principal, which is this value from here. It's the 10,593.33 plus whatever. Oh, and it's starting. I didn't want it to look jumbled, but it's doing it anyways. 93.33. We would like to add the interest that we're going to get during this period, which that interest, of course, is going to be the principal times the rate times the time. And that principal is the 10,593.33. And then times the rate, which is 0.07, and then times also the time. And the time in this case, it's been going on for 60 days. So the 60 days, and it's ordinary method, so out of 360. That's how much time we've gotten interest up until now when we make another payment. And so this is going to be $123.59. I will round up this 8. This is going to be the new maturity value. We will go this one. Oops, didn't mean to zoom in so much. This will be the one that goes 10,593.33 plus $123.59. Very good. The new value is going to be $10,716.92. That's how much you owe after the interest from day 40 up until day 100. And then we make a partial payment of, how much was it again? It was $4,000. That's our partial payment. So we should subtract $4,000 from this one. This will take care of the interest that we've gotten up until now. And then we will be starting over after this point for the last little stretch of this loan with the new value. So it's going to go 10,716.92, and then we're going to subtract 4,000. So that's going to be $6,716.92. That's going to be the amount that we're dealing with for the last 60 days, because of course after day 100 there's 60 more days. And there's no more partial payments to deal with. In this question in general, it's asking what is the final amount due on the loan. And the final amount that's due is going to be basically that maturity value on the last day, which is going to be here on day 160. So we need to take this one, which we're basically treating this as a new principal, and we need to add, to get this maturity value, 6,716.92 plus whatever interest we're going to get right now. And so the interest is that principal, the 6,716.92. That's how much you owe at this point. At the beginning of this 60 days, on day 100, that's how much you owe. So we're wanting to add this interest. What should we do? Also times the rate, which is 0.07. And then times, of course, this stretch, we've already dealt with all the interest up until here, up until day 100. We've dealt with it, and we don't have to remember those days. So right now, there's only 60 days left. So we want to add the interest for 60 more days, which means we should go times 60 out of 360. This will be the interest. Oh, I did the wrong thing. I'm going to go back to that entry. I didn't want to multiply so many times. This should be a divided by 60 out of 360. That's much better. $78.36. $78.36. If we add that amount, and I keep doing that, if we add that amount to the $6,716.92, we're almost there. and it's going to be $6,795.28. That's how much you owe at the very end. That's how much you will have to repay on day 160 at the end of the loan, thanks to your partial payments and so forth. You were able to cut out some of the interest that you would have accumulated otherwise, and you owe less in this case than if you had just let the whole value carry on for all the 160 days. You could check it yourself. If you would have just paid it all off at the end and not made the partial payments, it would have been a little bit more than this. You saved some money. But this is going to be, and to be very principled, I'm going to put dollars there. $6,795.28. $6,795.28. That is the amount, right? It looks correct. $67.95.28. Of course, your values, you're going to have different numbers, but that's what we got from doing this problem. So thank you guys for hanging in there. If you made it all the way to the end of this video, I know that probably problem number 13, it's the most difficult on the whole homework by a long shot. But thank you guys for watching. Please let me know if you have any other questions.